Okay, today we figure out, how in the world does Vegas know they're going to win? And when they set up these games of chance, we learned that a couple hundred years ago, they finally started, these gamblers went out and tried to find people that could help them figure out whether they're going to win or if they can win money from people. How did they go about doing that? How did they set up the problems to do that? That's what we're going to be talking about today. All right, Dalton, for the warm-up, I asked you, stop copying notes, we're doing this now. For the warm-up, I asked you to take these numbers and create a probability model from these numbers. What does yours look like?
X and gives.
Yeah, we find the probability of it. Okay, so what were the...
1, 3, 4, 7, 8.
A couple of things I like about this. I saw in some of your homeworks, but a lot more in the other classes, we learned about what a random variable was yesterday. And a random variable is a number that you get from output. I saw some probability models on homeworks that had like heads, tails, and ones and ones, twos. No, a random variable will give you a number as its output. All right. What I like about this also, there were no 2s or 5s in that, so we don't need to put them in here. What we want to put here is all the possible outputs that we can get, which you did a nice job of. Okay, so what's the probability of getting a 1?
7 over 20.
Yeah, I can take this either way, 7 over 20. Maybe some of you created the decimal out of that. You don't need them both. Just one of them's fine. Okay. Next one?
3 over 20, 6 over 20, 3 over 20, and 1 over 20.
Okay, good. That's all I wanted. Just create a probability model for this. All right, then from your calculator, put them all in L1. And I want you to find the mean, standard deviation, and the variance. What'd you get for the mean?
3.45.
That's correct. How about standard deviation?
2.33.
Now, careful now. I want you to use the sigma one, not the sample one. So I want the one that's the sigma. We're going to talk a little bit more about symbols today, but what was the one for 2.26? That's correct. And then we want to, how do I find variance?
Variance is r squared.
Not r squared. Variance is the, you're thinking of coefficient of determination, where the percent of the variance.
Explain that.
But what is this? What is variance in general? Mason?
It's the sum.
Come on, man. This was part of your warm-up problem. To not have any idea what variance is when it's part of your warm-up to figure out just doesn't fly at this time. Skylar, what's variance?
Standard deviation squared.
Yeah, it's just standard deviation squared. Remember when we found standard deviation a long time ago? We all got dressed up. First thing we found was variance, and we square rooted it to find standard deviation. So if you've got standard deviation, you can find the variance by squaring it. 5 point something? 5.107, 5.11, roughly. All right, well, here's the first thing we're going to learn about today. We're going to find this thing called the expected value. What if, instead of giving you these numbers, I just gave you the probability model? Could you, from just the probability model, find the mean, the standard deviation, and the variance? And the answer is yes. And here's the formulas that we're going to use. They're in your formula sheets. Go find them on page 4. Not one that you have to memorize. Right underneath the probability ones that we had for this last test. Crazy formula we got for this thing. All right, first of all, it's finding the mean of this distribution. That's what we're finding out. We're going to talk about expected value and why it was called that in a second. But really what we're calculating is the mean of this distribution. What would be the mean of those numbers if we were just given this? I'm going to want to introduce this chapter. Just gives you a little bit more information about these different symbols. Remember, this is mu. Remember, they both stand for the mean of something. This is mu and this is x bar. This one, here's what they told us in this chapter. It's a little bit more information. I'm pretty soon I'm going to give you a lot of information on this. What it means is it's the long, you do things many, many, many times. You know, what the average is going to come out to. This is the one that we use. Let's say I'm trying to figure out the average weight of Elk Grove High School students. And I go take a sample of 100 of them and I get their average weight. That would be what we'd use for the X-bar. But in the long, long run, what the real average is going to be in the long run, we use this symbol. And that's what we're going to be finding here. You'll see how this works in just a second. All right, big ugly formula. Now remember, whenever you're asked to find expected value or the variance, you're going to first write the formula down. You can do this many times tonight. All right, now how does this formula work? The X's stand for, obviously, your random variables here. And then the probability stands for their associated probability. So we're going to multiply those two together, okay, and then we're going to add them all up. So what is this going to look like, or what I'll want to see on your paper? So it's going to be 1 times, and I'll just do the 0.35. Plus, that's the summation part, 3 times 0.15. Plus, now, sometimes these get long. You've got about 20 of these things. So I don't want you to have to, like on May 10th, have to write all 20 of them out. So what I want you to do is write the first 2, then give me a dot, 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 and then show me what the last one was. That way your reader knows you know how to do this. Let's go plug those guys in our calculator and see if that formula does work. We should get 3.45 if we did it correctly. So, 1 times 0.35 plus 3 times 0.15 plus 4 times 0.3 plus 7 times 0.15 plus 8 times 0.05. And if I enter those right, blammo, it works. Now that shouldn't freak you out, right? What is the mean? Don't we add up all these numbers and divide by 20? Isn't that how you found the mean? Take a look at this. 1 times 7. So there's your 1/7 you add up. 3 times 3, right? There's 3 3s, that makes 9. 4 times 6, that makes 24. And then they're all divided by that 20. So that should kind of make sense to you, how that formula works and why it works. Now, if I just give you this, and you don't know how many numbers there were, you don't know if there were 20. There might be 200 or 2,000. But you know, 1 shows up 35% of the time. Shows up 15% of the time, you still get the same mean or expected value. All right, I usually don't give this trick, but I'm going to give it. I think I just learned it a couple years ago from one of you guys taught me. There's a way to do this a little quicker in your calculator than this, but I just learned this last period. In order for it to work, I think you need to set your calculator up. So if you go to mode, no, mine doesn't even have it. Your newer calculators have it. If you go to mode and you go all the way down to stat wizard, if you've got like a stat wizard thing, so if you go down to mode, you keep going down all the way, you see stat wizard. Some of you have it, some of you don't. Turn it off.
Stat diagnostics.
No, don't do the diagnostics. You want diagnostics on. Stat wizard you want off.
My stat diagnostics.
I can see that. Okay, if you don't do that, you don't have to know this trick, right? Nobody ever knew this trick before, but I think it's a cool little trick. All right, there's a quicker way to then go get this mean number. Then have to write them all in there. So if you got that stat wizard thing off, if you go into your editor, and I'm going to put that probability distribution, this probability model, in my L1 and L2. So you guys are going to have to help me here. 1 was what? What was it, 7/20?
0.35.
And And you could put, this is nothing I kind of learned, you can do 7 divided by 20 if you want. It'll keep all the significant digits. I know that these, stop, but if you put the 7 divided by 20 in there, it'll give you that decimal. Then what do you have? 3? What was that? The next one was?
4.3.
That was 0.3?
Yeah.
And then what was the next one?
7 and 1.15. And 8.05.
Okay, so normally now, if you're asked to find, if you used 1-bar stat, you just put a whole bunch of numbers in 1-bar stat, and it's gonna get one of the lists, and it's gonna give you the mean, the standard deviation, all that stuff. However, if you do 1-bar stat, and then give it L1, L2, and this is if you have that stat wizard on, it won't do it for you. But if you do so if you do 1-bar stat, but give it L1, L2, your calculator says, oh, you're giving me a probability model. Hit enter, and it will do that calculation for you very quickly without having to write them all out. This is going to help you a lot on the next thing I'm going to show you. Okay? You okay with that?
What does it do if you have stat wizard on?
It brings up that thing that says enter the list, and I don't think it lets you enter 2 lists. So anyway, don't worry about that, but that's the deal. Okay, so how does this help us in gambling? How does this work for us? Well, this is what these people that figured out all of these probabilities that casinos use, this is what they do. Okay, let's play the game of roulette. I think some of you have done some problems on this before. It's a little ball, and it goes around, and it stops. It stops on numbers and colors. Okay. There are 18 black colors that it can land on, 18 red colors it can land on, and there's 2 green ones. And so one of the games, there's many games you can play on roulette, but one of the games is, remember what my dad did? He waited, and then he put all his money on one of the colors? Well, here's how that works. So if you bet a certain color, if you win $1. If you bet $1, you win $1. If you bet $10, you win $10. If you lose your $1. So we want to know, is this a good game? Do I want to play this game? Well, what we're going to go calculate is the expected value. Okay, so we're going to create a probability model for this problem. So we'll define our random variable here as, winnings, how much you're going to win. The probability of your winnings. So this is in terms of dollars. So, what are my 2 situations here in terms of how much money I could win? I might win $1. Now, what is the probability based on the way the roulette wheel is set up? What's the probability that I'm going to win? What's the probability that the ball is going to land on the color that I chose? 18 over 38. Yeah, there's 38 total places it can land. 18 of them are my color. Now, what's the other alternative for this? I might lose $1. And then what's the probability that I lose $1? 20 over 38. So once you've filled out all of the different things that can happen to the game, you go find the expected value. So go do that for this problem. Let's go find the expected winnings. Is really what we're trying to figure out here. So you write your formula down. You plug in your numbers. And then you find out what our expected winnings are going to be. Make sure you write your formula, plug them in. Negative 0.05. What is it? Keep going. Decimals. 2.6. So it's negative, so that probably is a bad thing, right? And it is. Here's what this means. In the long run, you play this game many, 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 many times. You will lose, on average, a little over 5 cents per dollar played. So if that means if I play roulette 5 times, am I going to lose?
Not necessarily.
Not necessarily. Remember, in the short run, things can be pretty unpredictable. You've seen people come back from casinos and told you they won. But what about the casino? What do they know? Remember when you flipped a coin so many times, it turned out to be exactly what it was supposed to be? The casino knows if $1 million is played on roulette in a given evening, multiply that million times this, that's how much you're going to have. That's what it's going to come out to after many, many, many plays. And that's guaranteed. So all the games in the casino, they've done one of these for every situation. Some of them are not as, some of them are minus 10 cents. Some of them are pretty close, maybe minus 1 cent. But they're all minus. Okay? In the long run, the casino is going to win that money. And it's guaranteed. Okay? Yeah.
Would they ever have one where you at least break even?
Like there's one game, back right. Here we go. I'm on tape now. I'm teaching you good ways to gamble. I think there's one game at the casino that's actually a break-even game. It's 50-50. But every other game is
Legit.
I think it's Baccarat. I'm not sure. That's some crazy game. They got a million games, all right. But anyway, they've done this for every single game. They found the expected value. All right, let's take a look at these other two formulas. You can find the variance and the standard deviation the same way. So let's go back to that original chart that we had. Okay, 1, 3, 4, 7, 8. I think I've got this many points. 3, 5, point 0.3, 0.15, and 0.05? Yeah. Okay. So how would I calculate then the variance? All right, here's the formula for it. You take the number minus the mean squared and multiply it by the probability. You've got to show me how you plug those numbers in. Then we can use our fancy calculator to get the answer. So this is going to be, I have to take the number, that's the 1, minus the mean. We calculated that before, 3.45. Squared times the probability of it happening, 0.35. Plus, go to the next number, 3 minus 3.45 squared times 0.15. Plus, dot, 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 show me the last one. 8 minus 3.45 squared times 0.05. Remember, variance is how far away the numbers are from the mean squared. Standard deviation is how far the numbers are from the mean on average. Now, I don't care. You want to plug all those into your calculator and find that value out, you can. Remember, I just showed you a pretty cool shortcut here, didn't I? Your probability distribution function, it gave us standard deviation. 2.26. So what's the variance of that going to be? The 2.26 squared. I said that was 5.1 something. And then square root it, and there's your number for standard deviation. So this will do the calculation for you, but you need to show me the formula, plug in 3 of the numbers, how you get that. If you want to plug all those in, fine. If you want to get them from your probability model 1-bar stat, that's fine too. Now what have I found here? So, well, I know the middle of these numbers is 3.45, but typically they're off from the mean 2.26. Yeah, about 2.26 away, typically. Okay, that's what standard deviation tells us. Okay, expected value, huge thing. Any problem you get, okay, you can find the mean of a bunch of numbers by creating a probability model, or any game of chance. Plug in the various situations and find what's expected in the long run. These are the two formulas. Questions, comments?